Hello, everyone. Welcome to one more interesting session on machine learning. And today we are going to understand what is pre-processing, or we are going to get started with pre-processing for building a ML model. So, machine learning is one of the most buzzwords of this century. Not only organization, but people or resources are looking forward to learn what is machine learning because it's hugely in demand. Before we get started, let us have a quick round of introductions about myself. I am Krish and I am having an experience of 10 plus years in the ML field on machine learning and deep learning projects. And I work with different domains. And I am associated with OdinSchool. OdinSchool is one of the upskilling platforms which helps you acquire new skills and stay updated with the rise in technologies. Okay, let us see what all things we are going to cover in this session today. We are going to build models using machine learning. Okay, so for that, we have to understand what is pre processing or why is it required to pre process data. Okay, what are outliers and how do we handle the missing values which are present in the data sets? Okay, what is standardization, normalization, and how do we create dummy variables? And also, we are going to touch upon some of the algorithms which we have. Okay, so let us get started on this. So, as we have learned earlier in our previous session, like when we think of building our data model, we need to have some data in place. With that data, we do apply some smart techniques using these algorithms, and based on these algorithms, we get a prediction. Okay. So this is in short, or in, and also what happens like in case your prediction is doesn't look good, and there is some errors. What we do, we again start with the training the model, and finally get a prediction unless we are happy with our results. So let us know a little bit more of what all things are going on inside the data modeling. So as I told you earlier, when we get data can be of any form. Okay, and data is represented by different kind of variables. It can be numeric, it can be string, it can be a tuple, it can be a list, it can be an integer, it can be a float, or it can be a boolean. In any kind of format, it can be. So what we do with that data? With that data, we first thing that we do is we do a pre-processing of the data. What is pre-processing? Suppose whenever you get something, you like say, like for example, when you went to buy leave aside that pre-processing is something is like data cleaning part or standardizing, or making the data ready for your model. That is what pre-processing is all about. Once your data, and we are going to talk in details about what are the steps involved in pre-processing, because it is one of the major steps for building a model. It contributes to, you can say, almost 60% of your efforts, which is all about pre-processing. Once your data is pre-processed and is ready, we do a train test split. What is train test split? In train test split, I mean like you have your entire population of data. So out of that data, I take some portion of the data and I trained the model with that data. Once my training is fine, I the rest of the portion, I test that data whether I am the model I have built using the algorithm is correct or not, and that is about validation of the data. In case my data, I'm not happy with my results, so again I go ahead and change some parameters. Okay, so we all these things we are going to learn, and again train the data, and finally once we are when again we check the validation or test out the data or test out our model, and once we are happy, your model is finally live. Okay, so what is pre-processing? In pre-processing there are lots of steps involved. Suppose like for example, you are thinking of preparing rice, okay, or rice, okay, so for that you have to make some ground preparation, like you have to boil water, you have to acquire rice, and and most importantly you have to have a gas oven in place. So all these things are, some are prerequisites, like you have to have rice, you have to have, you know um, uh, you have to have a gas oven and water. So these are prerequisites. The next thing that you have to do pre-process, you have to wash the rice so that no dirt comes in while you are cooking. So the thing that you are doing, it is again pre-processing before cooking. So similarly for the data point of view, when you get data, you have very unclean data, or might be a case some of the informations are missing. So we have to make changes to that data, or modify it, or transform it, so that your data is ready and we can go ahead and process the data and do our analysis with that data. That is all about pre-processing. Okay, let us understand how we have been talking about accuracy. We have been talking about validation. So, what is validation actually, and how we find out how my model is performing, or what is the accuracy? Because when you build a model, the objective of building a model is you first validate the model, whether based on your test data is performing well, and you check the accuracy. What is the accuracy? Like suppose it's like the number of marks the model is getting for their performance. Suppose you have 100 number of cases. Out of those 100 number of cases, like you find like around 60 70 odd observations are correctly mapped, or correctly it is predicting. So you can say 60 to 70% is your data accuracy. So what is the accuracy formula? Number of correct classification, or number of correct results by total number of test cases. This accuracy will apply for only classification problem, because in classification problem you have either it can be a yes or no, it can be blue or green, it can be win or loss. So it can be either correct or it can be wrong. So in that case it becomes very easy to check what is the accuracy percentage. But for a regression problem, when we are checking what is the value is going to be, or predicting what is the value is going to be, for that we have a different score. For checking the accuracy we have r square. Okay, so we are going to talk about that later in our course. Okay, so how the model happens? So we have, as I told you earlier, we split the data in some portions. Like majority of the portion, we take it as our training data. It might be your like around 70 to 80% of the data we spend for training this data set. And in that training data set, we use machine learning algorithm. And finally, we build the model. So once we are happy, here also you'll get in the model you have different statistical values you are going to see. Once your model is ready, you validate it using the test data. That is, what is validation? You again you with the trained data you build the model. So you use the test data which is remaining, like 20 to 30%. You test it out whether your results are going correct or not, and from there you find out if your validation, this is the validation thing, and from there you get the accuracy. Accuracy is number of correct classification over number of test cases. So this is for a classification. For regression we tend to find out how close there are. So that is find out like what is, like for example, my actual, like as I told you earlier, I want to build a model so that I predict the price of the house. Okay, so again I have trained data and test data. My test data says my price of the house should be around say 90Ks. Okay, but my results gave me, like it has given me 75Ks. Okay, so the difference that you are getting, okay, so that is the difference of 15Ks divided by the actual of 90Ks is your R square, or that is the error that you are getting. Okay, so this is how you get the R square. So this is how you find out the accuracy. for classification, and for a regression problem. I'm going to show you those how you get the accuracy in later in the course. Okay, so let's talk a little bit more about the pre-processing of data and why it is required. So when we pre-process the data, we are talking about structured data. What is a structured data? Structured data is something which is can be have a structured format or can be in a tabular format. So the data which we generally use, like it can be numeric, it can be categorical. Okay, so first you have the data. The next thing, the job is to consolidate the data, because whenever you are building any model, you get data from different sources. The first job is to have a flat file. Otherwise, it, like for example, if your data is spread over different tables, it becomes very difficult to build a model where one information is present in one table and second information present in a different table. Suppose want to build a model to find out what is my churn rate going to be. Like for that, my table 1 contains customer information, table 2 contains the transactional information, table 3 contains product information. So when I am building a model, I need to have all these three tables joined. All these three information are vital for me. So what I'll do, based on the customer information and the transaction information, I will map them using the transaction ID. Now for the product information and the customer consolidated information, I map it using the product ID. And once those things are joined, so we have a consolidated data. So that is also a very, very important part or very, very important job of a data scientist, or for that is also part of pre-processing, where you create a flat file or a consolidated data. So once you have the consolidated data, you find out whether your data is clean or not clean. For clean and not clean, we have got different tests and different parameters to understand whether your data needs pre-processing or not. So not only we do pre-processing, but also we do a couple of transformations if required. So we are going to talk about these pre-processing things in very soon in this course now.
Okay. We have been talking about like working on structured data, consolidation of data, and requirement of cleaning and not cleaning. Okay, so the reason I'm talking here, so why do we have to consolidate the data? The reason is data comes in different formats and in different sources. It's not that you will get just one file to work on and you just upload it and you start working. No, that's not going to happen. You have data which is collected over different formats, over different data sources. So as I was telling, you have got like customer information, transaction information, product information. You have spread across different data tables. Like if you have worked in SQL is the best data management tool, where you just based on different tables you get to work on, you compile the data and you have the final data to work on. Okay, there are ways where we get the like a sets of files. Like for example, I have got 5 files. Okay, and what I do, I put it in the Python environment, and after in the Python environment I start working on it. I put it in the Python environment, and post that I start working and do my joins in that. Okay, so let me just tell you what is a join. Okay, a join is like, for example, I have got two table in place, table 1, and I have got this one of the critical things which we will be working on. So this is, we have got two tables. We have been talking about like how we consolidate their data, but how do we combine these tables? So if you have worked in Excel, you have known what is VLOOKUP. If you have worked in Excel, you know what is VLOOKUP is. It's like you have got one table and using one of the identifier you bring the different another information from another table. Similarly, in SQL or in Python, we have got what we call a join. What is a join? In join, we have an identifier based on which we are linking both the tables. Okay, for combining tables, different tables, we use the function which is known as joins. There might be different kinds of joins. There can be inner join, there can be left join, right join, outer join, full outer join, and so these are some of the joins which are available. So I'm not going to talk in detail about the different types of joins, but I'm going to show you how it is done. Okay, so this is the I have got three different files. I've got customer details, product details, and transaction details. So my job is to create a consolidated data. Let's first have a look at these files, and then I will understand how I go ahead in joining the files. So your first step is just open any of the files. Let's open the first one, customer details. So I can see I have got customer ID, contact number, name, email, order status, product ID, and FSN ID. Okay, so we can say like these IDs can be our identifier. Okay, like customer ID, product ID, and FSN ID. FSN ID can be talked about like it's like a transaction ID. Okay, product ID, yes, this will work. This will also work. Okay, everything is clear for me. Okay, let's open the next file. Let's open the product details. So I have the product ID as well in this file. So okay, so you're getting based on these. So this is the product details file, and this is the customer ID file. So we can combine them. That's great. And look at the third file. So okay, we have got FSN ID as well. Okay, it makes sense now. So based on FSN ID and product ID, I'm going to bring the customer details in on these files. So when I'm looking at information, I want to understand what this customer has bought during a certain period. So for that, the join where you are or the VLOOKUP that you are going to, here I am working in Excel, so I cannot apply a join. So I will be using a VLOOKUP in this case. So you have to understand what is your base file is going to be. Since I am talking about customer, product details, and transaction details, I am more concerned about like the duration is for which duration. Let's suppose I am taking for a couple of months duration. I want to see what the customer has bought during that time. So for that you have to make sure like the transaction details will be my base file, not this one. This is a product details, because based on which I am going to do my join. So if you look at, so what I'll do, I will select the Feb month and March month, and this is the information which I am concerned about. So because had I taken the customer details, I would have got the distinct information. So you have to based on the data, you have to understand what this data is talking about. Like in customer ID, there are slim chances where a customer might have duplicate columns, but in transaction ID, in transaction details, there might be a case where a customer has bought a couple of products, so that's why it has generated multiple transaction IDs. But I'm not going to talk in details about these things. So it's like based on your first judgment and based on your first analysis, you're going to understand. Let's create a new file. Okay, and I paste these things what I have based on the duration I have selected. Now the next job what I am going to do, so you can close this transaction details file. because this is done. Let's name it. Let's name, say, I can name it data, because this is the first set of information that you're looking for. Then I have got the product details. So I'll be concerned about the product MRP, okay, and the category and all these things. So I have to bring these things in my compiled data. Okay, so this is my data set. So I have to bring the customer information and then the product details here. So what I do, I have to do I bring the column names. So I go to customer details and I select the first few column names and I paste it here. So I have to do a VLOOKUP here. So VLOOKUP, you just freeze it, customer details 2, 3, 4, 5, 6, 7, 2, 0. Okay, then this will become 3. You see, everything is coming up. 3, this would be 4, this would be 5, this would be 6, this would be 7. So what I do, I just copy that and paste it here. So okay, these informations are not available. Next, I have to bring product IDs. Okay, so how do I do that? So this one is done. Product details, I have the product ID and I just bring these things. Again, similar logic, we look up this one, product details. Okay, I just forgot to freeze here. Two, 3. Just copy and drag it here. Okay, now I just break the links. Okay, your file is prepared. Let's close the rest of the files. It's not required. It's not required. So my final data set is ready. Let's clear the rest of the things. So for a data scientist, the first job is the first job is to data compilation. Okay, so that is done. The next thing is all about pre-processing. Okay, so the requirement of a pre-processing. So if you just have a look at this data set, you'll find a couple of /n's, a couple of #nas. Okay, what has happened? So if you look at this, just browse through it quickly. You'll find there are a couple of #nas, there are a couple of /n's, and might be a case there are not sure whether they have any blanks or not. We are going to find out later. Okay, so this my file is ready. So now what my job would be is putting this data into the Python environment. And once the data is in the Python environment, I will start ahead with my pre-processing. Okay, let's move to Python now. Okay, so this is the Anaconda environment and I launch Jupyter. Okay, so I have opened Python. Now let's move to the folder. First, program. So again, for importing the data into the Python environment, there are two different ways. But we are going to use the OS library for importing our data. We can use this program for doing a job. Okay. So, but what we do first whenever you open this is restart and clear all inputs. So we are not using these. This is, we can just comment out because that is not required. Okay. So we will be using this. We won't be using this because that is not required. You can just again comment out and insert the column here. Okay, so just copy this code. Okay, prior to this I have to import my library. You can just delete as well. So you can just select and do the cut and it is deleted. So you'll need this library, create import OS. Now see where is my data present. Okay, it's in Dell desktop data. So Dell desktop, and you have to just change the directory and type in data. Let's type the data. Okay, so let's see. Okay, let's give the data frame a name, and it is an XLS format, and I import it. Okay, your data is imported. Let's see how my data looks like. Let's take the header. So I'll press alt and enter. Oh, your data is imported. Let's find out the information. Okay, let's find out data dot info just to find out what the format of my variables are or my datasets are. Okay, here you will have an idea how many variables are missing, or what number, or how many data you are, how many variables you are having, what variables are of which types, and how many null values are there. Okay, you see the total number of records you have is 196 entries, which is mentioned here, but you have like around 4 or 3 null values. So that's the reason we have to do some pre-processing. Let's look at the tail of this data so that if you can get an idea how the tail looks like, or we can find any blanks or hash NAs or anything. We know we have your data contains hash NAs, and also on top of that it contains a couple of blanks, so it is looking clean here, but in between there are a few records which are not clean. Okay, now just look at the you have an idea like what the tail is looking to be. Now just have a quickly look at the data types present in your data. For that I write data types, control enter. Okay, so the year is integer, month is integer, order ID is integer. You see, look at the issue here. Like FSN ID is okay, it's an object, that means it is a string. Order ID is order date, is date time, that's perfect. Year is integer, month is integer, order ID is integer. Order ID should have been string, because what happens, the issue here in Python is if based on whatever format the data types are, it's going to treat it in such a way. Like for example, if your order ID is an integer, it's going to do some manual calculations, like you cannot have any order ID in a decimal. Okay, So those things we have to take care. Like GMVs and integers, that's perfectly fine. Delivery bad days object, delivery good days, so that those are object because those have some characters in them. So we are going to see to that contact number is float, name is object. Okay, everything is fine, but we have to take so we have to change the format of some of the data types. Only then we will be able to do a good analysis. Okay, when we are working with data, there are a couple of things we should remember. First job is data compilation and data collection, you can say, because the challenge arises which data to consider, which not to consider, and in that your some of the time or bandwidth is gone. Once you are fine like which data you're going to consider, and you have compiled the data, you have bought it using MySQL or Spark or MongoDB or any other data source. The data source can be of any format. Data can come in. Okay, you once you're fine with the data set, the next step that you're going to do is all about pre-processing. Because pre-processing is one of the major steps for building a model. If I say building a model, it will be just say 30 or 40% of your efforts, but 60% of your efforts is done for the pre-processing. Because if your base or your data is not clear, and your data format is not clear, then your results that you're going to be is going to go berserk. Okay, like for example here, if order ID is not changed to an object, you are going to get a very bad results. Let's see how the I change the format of these data type. Okay, let's take data. Now let us go ahead and change the data format. So for that, we have to first select the column, and then we have to change that to the data type for which we are looking for. So how do we select a column name? So you first the data frame name. Data frame is based on the table that you have created, based on which you have imported the data. So you write the data, and then within box brackets under quotes you write the order ID. Okay, so this is the thing you need the transformation. So again you write, select the same thing, and you type you're changing the data type and change it to an object, and press alt and enter. Now just double check on this data dot d types. Okay, let's look at. Okay, you have changed the order type, order ID. That's correct. Now let's move in and change the other data formats as well. What you can do easily, for quick and easy, you can just copy that and paste it here, and just change the column name which you are looking for. Object, float, contact number. Yes, you have to change this as well, because contact number can never ever be a numerical. You can do never a numerical function on that. So customer ID is again float, so you have to change that. So these are some of the things which you have to remember, otherwise you are going to face a lot of issues. This is again part of pre-processing. SLA factor, object, no issues, units, GMV, order, item, ID. So this one again is creating an issue. We have to change the data types. Let me see if we have any other thing which we needed to change. Order ID. So now the issue will be year and month. Year and month, if you do not change it, you are going to see you is going to take it as treat it as a numeric value, and it's going to find out it's going to find out different do some calculations on the year, so which is not possible. You cannot have a fractional year. Yes, in years you can, because in 2020.5 you cannot have. Similarly for month, So you have to just change the format. Okay, you can keep it object so that nothing is taken care of, and you can do that and press alt and enter, or you can do a control enter and just check the data types now, and you'll see everything is correct. Okay, let's look at the integer, GMV, units, yes, SLA, yes, float, and these. So your data is correct now. Now for pre-processing, there is an important step which is known as investigation, or which is known as EDA, or exploratory data analysis. What do we do in that? In exploratory data analysis, we find out what insights is present in the data. We find out what all trends is present in the data. We find out what all relationship there is in present in the data, and also we find out what is our target variable. Okay, so what is our target variable? So in house prices example I told you about, we wish to predict the price of the house. So but here, what is the thing that you are predicting, or what is the thing that your concern is all about? You have product details, you have customer information, you have transaction details. So what is that thing that is driving it? You can see GMV. So this is the price of the product the customer has paid. So so this is your target variable based on which everything is dependent, because this is a customer data. So the GMV, the product price the customer has paid. So the number of transaction he is making, the number of the product categories he is buying, everything is dependent on these GMV. So that is what our target variable is. Okay, we have got let's talk about some of the dependent and independent variable. Dependent variable is that variable which is our target variable, or which we are forecasting, or which we are predicting. And independent variables are those variables which we are using to predict the dependent variable. That's it. Okay, for the I will show you one more library. So which is based on which we will be doing our EDA. This is one of the simplest library and will make your EDA very easier. It is known as pandas profiling. Okay, so let's see how to install pandas profiling. Let me, if you are new to if you do not have any idea of which uh, library to install. Now you know the library name, but you do not know which library it is related to. Like pandas profiling, if I type pandas dash profiling, it won't work. So to be on the precise, just type it install pandas profiling, and it's Google is going to tell you how you're going to go ahead and install this library. Okay, dash profiling. Okay, let's open our command prompt. So just type in pip install pandas profiling, and your pandas profiling will be installed. It will take a few minutes to get downloaded, because with it comes a few of the supporting packages which also gets installed in your system. Let's wait till the final will get installed. Okay, your library is installed. Now let us see. You have a little bit of description how to use it, and how to create the Docker, how to call this library. Everything is mentioned here. Okay. Okay, so I'm going to call this library first. So I just paste it and press Alt Enter, and my library will be imported. The next thing what I'm going to do is create the profile report. Okay, so this is the data frame name. So that's so easy. And press Control and Enter. You will see the what is happening. Let me type in this one. Let's see, because sometimes it gives you issues here. Okay. The issue is here is because the name of the file names have got, you know, the name of the column names. You see, contact and number, customer and ID. Let me quickly correct that. Otherwise, it's going to face issues with it. Okay, this is correct, this is correct, this is correct. This is because it gives some issues sometimes. Customer ID has got a blank in between. So remember one thing, like you are making changes here, so you have to make changes in the code as well. Order status, product IDs. Okay, so this is done. Now we have to make changes in our codes. So customer ID, contact number. Okay. Okay, so what I do, I just go to kernel and just rerun everything, and everything will be executed. These kinds of issues we are bound to face in Python. You never know where the issue is coming from. Okay, there's one more issue. Return broadcast index of shape 15. Let me just check on this. What I do now is I just rerun the entire code and let's see how it works. It will take some time to get this populated. So pandas profiling is one of the most interesting libraries, and it will save you a lot of time for the EDA part. And it is very informative in terms of like uh, if you quickly want to find out the gist of the data, or what the data is talking about, how many blanks you have, how many outliers you are having. how's the distribution, what is the relationship between different variables. So all these sorts of answers will get solved using this library. So there are two ways where you can do. You can just ignore. You can just put in even your pandas. You can just remove this part and run the code. It will work. Okay, but you have to make sure, like the error I got, you might face some issues which you have to take care of. So my report is generated now. Let's have a quickly look at it. Okay, so you see, so where, okay, let me just scroll it. So you have the overview. Okay, so number of variables is 24, number of observation 196, missing is 51, duplicate rows 1. So it will give you each and every information that you're looking for. Reproduction, how it has worked, warnings. Let's see what warning it has. Here has constant. So these are some of the insights which this library throws you. Like name is highly correlated with 6 other fields, person is highly correlated with name, and these kinds of information which you are going to have. Procurement product SLA has got almost 2% missing values. Now, so this is what, so these are some of the information you are going to get. The number of missing, number of unsupported, and all these things. So in terms of variable type of information, these things you are going to get. How many distinct are there, how many unique are there, how many missing are there. Based on each of these variables you are going to get. It's just a report summary which you will be getting. Okay, it's very interesting. So this is let me just scroll this for you. Okay, so this is an interaction graph which is, highly, contact number is coming. It shouldn't be. So let me just see. Contact number, it shouldn't be taking as a string. Contact number is object. Okay, got it. Okay, this is an interactive correlations interaction interacting interactive interface that you're going to see. Like for example, I want to find out the relationship between GMV and SLA. Okay, not that information, not that, product. That's not interactive is coming. Let's look at the correlation summary. Let's select product SLAs and contact number, product MRP. So I'm not getting anything. Okay, let's look at the cross correlation which you're going to get. The Pearsons, Spearmans, Kendalls, and Pills. You have got Kramer's. Kramer's is for the categorical variables where you get the different, uh, where you get the relationship between different categorical variables. That's what Kramer's V is used for. For Pearsons and Spearmans, these correlations are used mainly for numeric variables, like for example, GMV, units, SLA, and all these relationships will be coming. If you see, it has got highly negative correlation, product procurement, SLA, and customer IDs. Now, so correlation is a relationship between two variables. It can be, the range is from -1 to +1. Minus means it is negatively correlated, like one increases, the other will decrease. And if the correlation is positive, like if one increases, the other will also increase. That's what correlation is all about. It's a relationship between two important variables. So Spearman's and Kindle is for numeric, and Kramer's is for the categorical. So how many missing, matrix, heat maps, dendrograms. So all these kinds of information you are going to get from these. And lastly, it will give you a sample of the data set, the first 9 to 10, the first 10 rows and the last 10 rows of your data set. I'm going to also share with you what duplicate data you are having in your data sets. So that's about pandas profiling. So that is so much interesting. So based on these, we can see your maximum EDA or exploratory data analysis is done. Okay, so we have known so what is cleaning and not cleaning, and why we clean, we what is cleaned and not clean data, and why we do pre-processing. Okay, so let's have a quick round. Let's talk about all the things we do for the pre-processing. As I told you, data can come in from any kind of data sources, be it MySQL, be it Redshift, be it SQL, okay, Oracle, IBM DB, Druid, Cassandra, MongoDB. It can come from any of these data sources. Okay, the first job is to consolidate this data, where you create one flat file or the least number of flat files. Okay, the next you are going to do is change the data types. Like for example, as I told you as I showed you, you are changing the data formats, like where where the say date of birth is coming as a numeric, it should be changed into a string or a date type format, so that you do not do some manual calculations with it. So that is something which you have to do. Next is the missing value treatment. Okay, suppose if you have any kind of values which are missing or not present, so you have to take care of that. There are a couple of things which you can do with the missing values. One is you can remove the records where you have got missing values, or you just replace the missing values with some value of yours. It can be a numeric, it can be a string. In both cases you might come across missing values, and this is one of the critical problems which as a data scientist or which as an organization faces in terms of data. Outlier treatment. Outliers are, you can say, which just stands out or which are just out of the box. I'm going to cover this in the later part of this session. What is an outlier? Okay, variable transformation. Variable transformation is all about when we are changing the format, or we are, like for example, it's present in some currencies, we are changing the format, or you're combining these data with other variables. You might come across such things where we do such transformations, or where we change the data formats. Normalization and standardization means when we are changing when you have got data of different formats of different types, so just to maintain the so that we every data is in the same format, we do normalization or standardization. Dimension reduction is when we are looking for, like for example, you have got 1,000 variables, and it becomes very difficult to manage the 1,000 variables. What we do, we group those variables which are similar in nature. That's all about dimension reduction. Okay, for categorical variables, we do a categorization which is known as bins. Okay, what do we do in that? Like for example, we have got zip codes of the pin codes of different locations. So what we do, based on the location or based on the distance and based on the location, we group certain pin codes into one location, and based on that we do the analysis. And finally we come up across with EDA. As I told you earlier, it is about exploratory data analysis, where we find out insights into the data, we find out the trends in the data, we find out what these data is talking about, we find out which are our independent and dependent variables, and what is the relationship between the dependent and independent variables. Because when we are modeling, like for example, I just showed you earlier, we are finding an equation y equals to mx plus c, be it a linear or non-linear equation. our focus should be, though we should target those variables which are have high relationship between different variables. Suppose we are I'm wanting to find out the dependent variable, but I should take only those independent variables which are highly correlated with the dependent variable. Okay, let's talk about a little bit about what is EDA and what all the things we do in the EDA. We take the cleaned data. Okay, not we do not um, once your data is clean, like your data is out of outliers, your data is out of missing values, your data is in a proper format, your data in a proper scale. So once you have the data, we find out some descriptive statistics. Okay, you can say descriptive statistics. In descriptive statistics, we find out the mean, we find out the median, we find out the mode. Okay, we find out this kurtosis, find out the skewness. Kurtosis and skewness tells you about the distribution of the data, how skewed is the data. Skewness is flattedness or peakedness. Kurtosis tells you like how your data is distributed. It's just about the population of the data, how your data is being distributed, whether your data is normally distributed or not normally distributed. Also, we find out VIF. Okay, what is VIF? Variable inflation factor, variable information factor. What is this VIF? VIF tells you the relationship between the independent variable. It is also known as multicollinearity. Multicollinearity. Okay, what is this multicollinearity? This is a huge problem for building a model. Here, in multicollinearity says that your independent variables are highly correlated with each other. So, when we are building a model, you should make sure like your independent variables are not related with each other. Keep that in mind. The dependent and independent variable might be related with, should have the relationship very high, but between independent and independent between the independent variable there should be no relationship, or should be as less possible relationship. Between dependent and independent, relation should be stronger. Between the independent variable, it should be as less as possible. So VIF takes care of that, where your relationship between independent variable is as less as possible, and we take only those independent variable which are less correlated with each other. Okay, the next is we do feature selection. Feature selection is all about we are selecting which variables we are going to include in our model. Okay, so for that we have got different test informations like IV and RFE. Okay, and the last step is about class imbalance, or that is optional. Like for example, when classification problem, this is you're going to face these kind of issues, or like when we are dealing with fraud detection, where like for example you have got two classes, say yes or no, and you see like yes is almost 10% compared to no, where it is 90% of the data. So that is what class imbalance is all about, where we have to take care of the data. You have to take different weights and go about building the model. Okay, I was talking about outliers. So what are outliers? Outliers are those values which falls outside the graph, or which, if you see, look at the picture, these are just falling outside. So there you have a scatter plot, and these values are just falling outside the graph. So that is all about outliers. Okay, and missing values is if any information is missing, we call it a missing values. Okay, let me just show you. Come on, get back to your data. Okay, these are coming. Let me just open up this file for you, and I'll just show you what is an outlier and what is a missing value. So if you see, let's look at this column. Okay, delivery C days. You can see the maximum information we have are in numbers, whereas there is also a value which is coming as slash n. Slash n can also be termed as an outlier because this is an entity which shouldn't be present but is present. So similarly in customer IDs, you see hash n is coming. This is again, this is not an outlier nor a missing values, but this is something which is shouldn't be present. So these are junk values which will come in. Similarly, like slash n, these are junk values. So you have to remove these things. Now look at the GMV. You look at these two things that you're going to see. Are you Can you see these two values which are huge? So these are termed as outliers, where these are just falling outside the box, or these are just beyond. That is all about an outlier. Let me show you if I have got any missing values or not. So this is the best way to find out um, if we have got any missing values or not. Let's look at customer IDs. No, we do not have. We have junk values. There might be cases. Okay, and from the EDI I found like the how the delivery was made. It has a couple of missing values. Let me see. Okay, let's look at here. Okay, we have a missing values here. You see, data is not present. So that is all about missing values. Let me explain you about an outlier a little bit more. Okay, when you have your graph, okay, there are two things when you have got data. You have got two things that you consider. One is a lower control limit and the other is an upper control limit. Okay, my lower control limit is your 25th percentile. And upper control limit is the 75th percentile. Okay, and in between what comes is your 50th percentile. You know what is the percentile upon 100? That is your median. Okay, so whenever you have got any data set, we calculate the LCL and the UCL. LCL is the 25th and the upper control is the 75th. So most of your data will fall within this range, the upper control and lower control limit. And if any data falls outside here or outside there, that is termed as an outlier. Okay, so and the best representation of an outlier is a box plot. So what is a box plot? Box plot, as the name suggests, is a graph which looks like a box and which has got whiskers. Okay, so you have got lower control and you have got upper control, and there will be a median. Okay, so any data will which are falling in that in any data which is falling in this range is your data which is devoid of any outliers, but any data falling here or falling here are termed as outliers. Okay, that's the like box plot is one of the representation which helps you in very easily identifying an outlier. And from this data set we have also find out how many missing values, or which are the we found out the missing values and the outliers in our data sets. Okay, that's okay. So as I was talking about normalization and standardization, suppose your data variables are of different scales. So normalization is done so that it's of the same scale. Normalization and standardization, where your mean is 0 and standard deviation is 1. So what we do, we take the data and deduct it from the minimum, and we divide it by the maximum and minimum. So that's all about. So just to have of it on the same scale, we do normalization, or we can do standardization. Okay, the next thing that we are going to do with the data types is of the category. This is for dummy variable creation. Dummy variable creation we mainly do for the categorical variable. So let's see how this dummy variables is done. So we can look at this one. Let's take look at this variable. So what we do, we have the variables of COD and prepaid, and when we have got two classes here. So what we do in this dummy variable is, I'll just show you here, insert two columns. Okay, and we name it as, say, COD, and we name it as prepaid. Okay, so where there is prepaid, I type 1, and where there is COD, I type here, and the rest will be 0. So it is again binary coding which is done. Like whenever there is COD, it will be 1, and the other will be 0. So here you have prepaid. In this case, in this column, it will be 1, and the other column will stay as 0. So this is what dummy variables is all about, because it becomes very difficult when you are building equation, or you're building a model, or you're doing the modeling. So that's why we change the data format into dummy variables, okay, and for the categorical variables. And also what we do, we remove the main categorical variable, because this information is already information in these two columns. And also when we are dealing with like 5 or 6 or more than 10 dummy variables, so we take the number of columns as number of levels minus 1. Like here, we have got two levels, but we will be just considering one, because you see, if it is 0, that means the other part is present. If it is 1, it obviously means that this is present, that means the other is not present. So that's why the number of columns we will be using is just 1, that is number of levels minus 1. So so how do we do that using Python? We do it using the pre-processing library of sklearn. So we do not do it manually. Yes, we used to do before, when we were not using Python, but as of now, this is how we go ahead and build the dummy variables. Okay, let's talk about some of the algorithms which we have in machine learning. So these are most of the common algorithms which we use. We have got linear regression, we have got logistic regression, we have got decision trees, we have got random forest, we have naive Bayes, and we are going to talk about neural network. When we talk about linear regression is all about when we talk about a straight line. When we get equation like a linear relationship is there, we get a linear regression, and this is one of the most common technique when we are predicting any value. For logistic regression, it's a non-linear relationship that we are talking about. Okay, and the graph won't be a straight line, but it will be a curved graph, when we are talking about. And here in logistic regression, we talk about classification problems. Okay, and decision tree. What is our decision tree? You have heard about, you have seen the hierarchical graph in your organization. Our decision tree is also like that. It is a tree based approach which we get. Like we want to predict what's the uh, suppose we are working on a classification problem, and we want to find out whether this team is going to win or not. It starts with one of the nodes which is called a root node. There it will see like what is this, like for example, which country we are playing. Say it is a home country or foreign. It says it is we so it how the tree splits based on the entropy scores or different scores, or an IG value is information gain. These are all some of the terms which we are going to talk in details later in another course. But here it's, you can know it's based on different scores. We find whether this we define which is our root node and which node we are going to split. Okay, so whether it's going to be in foreign or in home. If it is home, so we say which what they are during which time the match is being played. Is it in a day night match or is it in the day? If it is day night match, okay, so who is batting first, or would, okay, team 1 or team 2. So likewise you have, it's a tree based approach which we get, and based on that our decisions comes up. A random forest you can say is a derived version of our decision tree, where instead of one trees we create couple of trees, and based on that, based on different votes, we find out the most efficient one, which is gives our correct results. Okay, naive this algorithm is mostly used when we are dealing with multi-class classification, or when we are working on like natural language processing problems. Okay, naive works on Bayes theorem. Okay, and lastly, the neural network. Neural network works on neural net, or just like a human brain. So how it works is like from one input, it takes the from one input, it creates an output, and that the second output will become an input for that. It's a layered approach where neural network is all about. So these things we are going to cover not here but in a separate course. Okay, let's recap of what are the things we have covered in this. We have learned about machine learning and how to build the models, why it is required to do pre-process, how we are removing the outliers and the missing values, how we are standardizing and normalizing the data, and we have a quick information about these algorithms. Thanks for watching this video, and don't forget to like and subscribe to my channel, and just subscribe to keep yourself updated with the upcoming videos. Thank you for watching. Bye bye.